Hello, class. Okay, so this is the second part of 5.1. Um, so this is just a quick review here of quadrantal t-values and their associated points, and the common t-values and their associated points. So these are the charts that I wanted you to memorize. So the quadrantal ones, those are the ones that are like on the axes, right? 0 degrees, 90 degrees, 180 degrees, 270, 360. Okay. Um, so the other three are those, the ones that we covered at the end of the video. Okay. So hopefully you have those memorized to some degree. Okay. So let's go ahead and finish up here. Okay. So 5.1 continued. Okay. All right. So now we're going to talk about reference number. Okay, so here's a nice big long definition. Okay, so let's let t be a real number as opposed to an imaginary one. Okay. Uh, the reference number t is the shortest distance on the unit circle between the terminal point and the horizontal axis. And I will draw you a visual. Okay, so, and the horizontal axis. Okay, so it's the shortest distance between your terminal point and the horizontal axis. Okay. All right, so here's a visual. So if you have your unit circle, okay, okay, and let's suppose that you travel around your unit circle in the positive direction. Okay, so suppose you go here. Here, I'm going to make it a little bit thicker. Hold on a second. Okay, so suppose you travel here along your circle and you stop right here. So this is your terminal point, right? So what they're saying is it's the shortest distance. So that distance is more than pi, right? Because we know the full distance, the full circumference is 2 pi, right? This is a unit circle. So 2 pi r, 2 pi times 1. So it's, the full circumference is 2 pi. Half the circle is pi, 1 pi. So we've gone a little bit more than 1 pi, right? So when they talk about the reference number, they're not talking about the full distance traveled. They're talking about only this part here. So the shortest distance from your terminal point, which is that dot right there, and the x-axis. So what they're talking about is this distance here, that short distance between the x-axis and your terminal point. Okay, so even though it's traveled just a little bit over pi distance, it's reference number is only going to be that short distance. Okay? I'll call that T. Okay. All right. Let me get my black ink. Okay. So finding reference numbers. Okay, so finding reference numbers. So let's take a look. Um, and they're all going to be related to these here on the chart. So your reference angle, well, at least the ones I'm going to give you here in the examples will be related to these. If you get some other numbers, the whole idea transfers over to whatever angles you have, okay, or distances you have. Okay, so let's take a look. Finding reference numbers. Okay, so let's do a few examples. Find, so I'm going to call it T bar for each T, okay? All right, so suppose that I have this T value, 5 pi over 6. Okay, so that's just shy of 1 pi, right? 6 pi over 6 is 1 pi, right? So we're just shy of 1 pi. We're 5/6. Okay. All right. So we want to know what the reference number is. Okay. So here, um, for me, it helps to kind of visualize this. Okay. So here, this tells me that your pi, your half circle, is divided into 6 equal pieces. Okay, so let's take a look at that. Okay, so here's your, I'm going to draw the full circle, right? 2 pi. So if I only go to here, I only go pi. But if I go full circle, I've covered a distance of 2 pi, right? Okay, so your half circle is divided into 6 equal pieces. Okay, I'm only going to need 5 out of the 6 pieces, so I don't need any more on the bottom. If I had more than 6, like let's say it said 11 pi over 6, then yeah, I would draw the ones on the bottom because I've gone beyond 6, right? Okay. If you have less than that bottom number, which is 5, okay, so we have 5 out of the 6, okay? So it's like we've gone, uh, we've gone here. That's not good because we're not there yet. We're not talking about angles just yet. Okay, so let me fix that. Okay, so okay, so we went 5/6 of the way, right? So let me take my red. Okay, so I went, so this here is 1/6, here is 2/6, that's 3/6, 4/6, 5/6. So my terminal point is right here. Okay. So the distance that I want is the shortest distance between the x-axis and that point. So the distance that I want is this right here. And we can see visually, we can see that is 1 pi over 6. Okay. So that's my reference number. Okay. Let's take a look at another one. Okay, so suppose that we have 7 pi over 4. Okay, which means that my half circle is cut into 4 pieces, and I'm going to need more than 4. So this time I will cut it down on the bottom as well. Okay, here's pi. If I go full circle, I go 2 pi. All right, so it's cut in my half circle again. So that's what this means. My half circle is divided into 4 pieces. So 4 equal pieces. Okay, but I'm going to need 7. So I'm going to need some from the bottom. So let me cut that into 4 equal pieces. Okay, so 7 pi over 4. So I go, that's 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, and 7/4. So my terminal point ends up here. Okay. And the distance I want, again, is the shortest distance to the x-axis. So that would be this distance right here is what I want. And we can see here that that is 1/4 pi. Okay. So here, my t bar would be 1/4 pi. Okay, hopefully that's making some sense now. Okay, so let's go ahead and try another one. Suppose that I have t equals negative 2 pi over 3. So now we're going to go the other direction. Okay, so draw my circle. Halfway is pi, and full circle is 2 pi. Okay, all right, so I'm going in the opposite direction. So I'm going clockwise. Okay, and again, my half circle is cut into 3 pieces. So let's go ahead and do that. Okay. And I don't need more than 2, so I'm not going to slice up the top. Okay, so I'm going negative. That's why I use the ones down below, because I'm going clockwise. Okay, so I have to go negative 2/3. -1, -2. Okay, so that's -1/3, -2/3. So my reference point lands right there. My terminal point lands right there. So the reference number that I want is the shortest distance between that point and the x-axis. So that would be this. Okay, and we see that that would be 1/3. Okay, and it's positive 1/3 because we just want to know what's that distance. Okay, so here t bar is positive 1/3. Okay. All right, let's do another one. Okay, so let's suppose that t is 5.80. Okay, so that's a weird number. How are we going to slice up our pi? Okay, so let me go ahead and draw my circle. Okay, so again, if you go halfway around, you only go a distance of pi. If you go full circle, you go a distance of 2 pi. Okay. So because we use pi, 2 pi, pi over 4, 3 pi over 4, all these fractions in pi, it's hard to remember that those are actually numbers and they can be easily turned into decimals. So we're all pretty familiar with pi. Pi is roughly 3.14. Okay, and so if we double that, then 2 pi is roughly 6.28. And if you haven't heard in the news lately, pi and 2 pi are kind of in competition for their day. I think a lot of us know somebody that celebrates Pi Day, right? March 14th. But maybe only a few of us know somebody who celebrates Tau Day. They call this one Tau, and that would be on June 28th. Okay, so anyway, so we have decimals here. So if we're talking about 5.80, so you've so it's saying that you're traveling around that circle to 5.8. So we know that, okay, well, we've gone this far, 3.14. So we know we've done more than that if we're trying to get to 5.8. 5.8 is closer to 6.28. Who knows where, but somewhere, right? But it's kind of closer to there than it is to 3.14, right? Okay, so it's somewhere over here. Okay. And so the distance that I want to know, the reference number, would be this distance right here. Okay. So if I've traveled, okay, so if I've traveled all the way to here, and this is 5.80, and going full circle will give me 6.28, then how should I find that distance there? Okay, I know one of you guys just said it. You would subtract. Very good. 6.28 minus 5.80. Okay, so here, so 6.28 minus 5.80. And so that gives me roughly 0.48. Okay, so I should really say roughly. Okay, 0.48. That would be your reference number. Okay. So it doesn't really matter if they give you decimals, if they give you fractions in terms of thirds or fourths or sixths or eighths or sevenths. So you would just need to slice your half circle in terms of whatever fraction they're talking about. If it's thirds, then cut it into thirds. If it's fifths, then cut it into fifths. Okay. If it's a decimal, don't worry about it. Okay. All right. Just try to find out where it lands. If it's closer to the 6.28 or is it closer to the 3.14? Okay. If you're not sure, you could always do the subtraction and see which one is the smaller distance. Okay. All right, so let's take a look at using reference numbers to find the x and y value. Okay, so you'll notice here, the ones up here up above, these A, B, and C all have reference numbers that are related to the ones that you guys had to memorize. Pi over 3, pi over 4, pi over 6. Okay, so when they're going to ask you to find the X and Y that's associated with the reference number, well, whatever t value they give you, it's probably going to have a reference number of something on your chart. Okay, so because that's the only way you guys would be able to know the X and Y value until we start showing you how to do all the trig. Okay. So using reference numbers to find X and Y. So your reference number will probably be a number on your chart that I asked you to memorize. Okay. So the one thing you do want to pay attention to is, okay, well, where does your terminal point land? Okay, so which quadrant? Okay, and then from that, determine if your X and Y values are positive or negative. And you'll only know that by knowing where it lands, what quadrant. And knowing which quadrant, so knowing which quadrant your terminal point lands in will tell you, okay, well, if it's in this quadrant, then my X is negative, or if it's in this quadrant, then my Y value is positive. So that's gonna determine your answer for your point that you're trying to find. Because remember, you're going to try to find the X and Y value. Okay, so you'll need to be aware of whether the X value is going to be negative or if it's going to be positive. Same thing with the Y value. Okay, because when you look at the chart, let's go all the way to the beginning. Okay, so when we looked at the charts here, um, for the most part, these right here, they're all in quadrant one. Okay, so now what's going to happen is your terminal point might be outside of quadrant one, but your reference number is going to be one of these three. Okay, in which case your XY point will be exactly the same. Okay, if you get a reference angle of pi over 6, then your X and Y will be square root 3 over 2, comma 1/2, with an exception of the positive or negative. Okay, so that's why it was important for you to memorize this chart, because if your reference value is pi over 6, your reference number is pi over 6, but you're in quadrant number 3, well, in quadrant number 3, your X value is negative and your Y value is negative. So you would have to say negative square root 3 over 2, negative 1/2. Okay, so, but for the most part, you'll be using that in this here. Okay, all right, so let's go back to here. All right, so let's take a look at some examples. Find the terminal point associated with T. Okay, and we'll do a few examples. Okay, suppose that we have T equals 5 pi over 6. Okay, so if you need to do your drawing to get a visual of it, then go ahead and do so. Okay, so over here, okay, so here's pi, here's 2 pi. It's cut into 6 pieces. Again, my half circle is cut into 6 pieces. So there we go, and there we go. And 5 pi over 6, so I go 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. So I am right over here. So my reference number is pi over 6. Okay, so my reference is pi over 6. And that's one of the ones you have memorized. Okay, therefore my point, the point that is associated with this is going to be square root 3 over 2, 1/2. But now let's take a look at the quadrant that it's in. Okay, so if you imagine an x and y axes here, right? Okay, there it is. Okay, so if you imagine x and y axes here, we see that the point is in quadrant 2. And we see that here, x values are negative, y values are positive, right? X values are negative. Here, let me use a different color so you can see it. Okay, so here, x value is negative, y value is positive. Okay, so here, I would have to say negative square root 3 over 2, 1/2. Okay, so that's why it's important to know where it lands. Okay, let's take a look at another one. So this would be your final answer right here. Okay, so let's try another one. Suppose that my T is 7 pi over 4. So we want to know, where does that land? So if you need to draw, by all means draw. Okay, so here's my full circle. Halfway is pi. Full circle, I go 2 pi. All right. My half circle is cut into 4 pieces. I'm going to need 7, so I'm going to need some from the bottom. All right, 7 pi over 4. Okay, so 7 pi over 4. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. Okay, so my terminal point is right there. I see that my reference My reference value is 1/4. Okay. Okay. And so therefore my point that is associated with that, hopefully you have it memorized, is square root 2 over 2, square root 2 over 2. Okay, so we know it's going to be square root 2 over 2, comma, square root 2 over 2. But let's take a look at the signs. So here, again, if you imagine X and Y axes, it's in quadrant number 4. And we know that the X value is positive, but the Y value is negative. So it would be square root 2 over 2, comma, negative square root 2 over 2. Okay, so this would be your answer. Okay, and again, you were supposed to memorize that chart from part 1. Okay, so let's take a look at another one. Okay, so suppose our t value is negative 2 pi over 3. Okay, so we have this here, and we're going the opposite direction. So, and it's cut into 3 equal parts, and 2/3, that's 1/3, and 2/3. So I'm over here. Okay, so my reference number is that short one. Okay, so this one over here. That's my reference right here. Okay, and we see that that is 1/3. And it's, again, one of the ones you have memorized. Okay, so it's 1/3 of pi. And hopefully you have it memorized. So it's 1/2, comma, square root 3 over 2. But it is in quadrant number 3. Okay, so in quadrant number 3, so if you can imagine, there it is, quadrant number 3. You can see here your x value is negative, but your y value is negative. So both of these are negative. Okay. All right, very good. Why don't you go ahead and try this one that I give you, just to make sure you've got it. Okay, so go ahead and try this one. Suppose your t value is 4 pi over 3. Okay, go ahead and find the terminal point. So go ahead and hit the pause button right now, because I'm going to work it out as well. And then when you're done, go ahead and hit play to see if you got the same answer that I get. Okay, so here is the answer. So you should have gotten T bar, your reference number is pi over 3. And hopefully you have that one memorized. You should have said that this one here is 1/2 square root 3 over 2. But you are in quadrant number 3, which would make them both negative. Okay, so if you need a visual of this, okay, so let's go ahead and draw our half circle, cut into 3 pieces, but we're going to need 4. So let's get the full circle. Okay, so 4/3 So 4/3 lands over here. Okay, so that's 1/3, 2/3, 3/3, 4/3. So my point lands right there. Okay, and my reference angle is actually, ooh, my device is getting tired. Okay, so your reference angle is actually this distance. Okay, which is 1/3. Okay, so your T bar is 1/3 pi. Okay, and you were supposed to have that one memorized, which is 1/2 square root 3/2. And then again, if you try to imagine your x and y axes, we see here that it's in quadrant number 3. So where the x values are negative and the y values are negative. Okay, so that's pretty much it. Okay, so if you have any questions, make sure you email me or message me. Or, if you feel like you want a little bit more explanation or want me to put up some problems for you to try here, uh, and I'll have the answers and I'll have them worked out. That way you kind of get this practice kind of with me. I can do that too. Just let me know what you guys need to, so that you are successful with this next test. It's one of the harder ones just because of all the trig, if you haven't had any trig. Okay. All right. That's it. So I'll see you next time.